Ladies and gentlemen, as AI applications become more sophisticated, we're discovering that dedicated vector databases might actually be solving the wrong problem entirely. This is the shock that one team actually discovered when they ended up paying $2,000 a month for an index that should have been deleted 4 months ago. And that's not even mentioning the risk of returning incorrect or stale data of your users. And so I bring to you today a panel of experts, of people who've been deeply in this industry, from Timescale database all the way to a young prodigy by the name of Dhravya from Supermemory.ai. And so we have Matt to join us, as well as Avthar, and they're going to give us a lot of insight today on this entire problem. Is that, like, are we approaching vector databases to solve the right problems or not? Is this the actual abstraction that we should be solving for? And this is something that I'm encountering as I am building my own AI apps as a solo entrepreneur. But also a couple steps ahead of me and many steps ahead of me, we have Dhravya from Supermemory as well. So welcome, guys, to the show.
Thank you for having us.
Cool. Yeah, I'm excited because if this episode is going to be for those people who are currently building AI apps, who are working in this space, and maybe if you're just getting started, this could also be very insightful for you as you're picking your different databases and different things to make sure you have your different applications that are going to be pulling out and extracting insights. And so I'm kind of still at the early stages of this. I've worked in engineering. I kind of have a lot of questions, but whenever I start reading about things, they always kind of light my mind and saying, oh my gosh, am I actually getting into the wrong thing, or did I get started at the wrong place and so forth? And so I'm excited to have you guys. And Dhravya, I'd love to have you introduce yourself a little bit about what you're working on, and then I'll have then followed up by Avthar and Matt, a little bit of from what you guys, so that people kind of know what we're going to be getting into.
All right. So thanks for inviting me, Ray. And I'm really excited for this. I'm a huge fan of Timescale. Anyways, so I'm Dhravya. I'm a 19-year-old builder originally from Mumbai, India. And right now I'm working on this thing called Supermemory.ai, which is a knowledge-based platform where you can import content from anywhere you have been collecting it, and then have chat and search and suggestions and other stuff over it. It's a pretty simple app, but it requires vector databases at scale, and that's why I've run into vector DB issues. So yeah, that's a little bit about me.
Excellent. Cool.
I can go next. Yeah.
Yeah,
So
yeah,
hey
go ahead.
everyone. Hey everyone. My name is Avthar. I work on the PGAI team at Timescale. So we're building a suite of tools to help software developers build AI systems much more easily, much more performantly, using the Postgres database that they already know and love. And so we built out a set of open source tools that includes PGVector Scale to help scale Postgres for vector workloads, PGAI, and then most recently PGAI Vectorizer, which is kind of what got us on the stream. So really excited and excited to hopefully teach and also learn new stuff on the stream.
Excellent. Matt.
Hey, I'm Matt. I'm one of the founding engineers at Timescale, so have been working on databases for a really long time. Recently, I've been kind of heading up the AI effort at Timescale from the technical point of view. And yeah, after just mentioned all of the stuff we're building, and the overarching connection between all of these things is trying to make it easier for people building production grade AI applications.
Excellent. Yeah, this is really good. What really kind of got me, and kind of why we're starting the stream, is because I saw this post from Avthar that says vector databases are the wrong extraction. Here's a better way, introducing PGAI Vectorizer. And so this tool, basically automatically creates and syncs embeddings with source data, just like a database. So for those who are just following, for me especially kind of being new to this space, the most common thing that, I started playing around with was just literally chat with the PDF. It's like, cool, I want to put all these types of things in. And a lot of tutorials I saw on YouTube were just like, yeah, just use, Pinecone, use these types of vector databases. So then you kind of start kind of getting into this, and you figure out after you upload a 200-page document, and you're like, it doesn't really get everything that I wanted from this document. I have to figure out how to actually chunk these types of things. Or, it comes out with a ranking of 10 different things and the one I want is actually number 8. And why did it do that? So you start to learn kind of some of the basics of how these types of things work and start tweaking these knobs and parameters. And so for me, it just started to get like, it's like, wow, okay, like, is this kind of the world I'm going to start living in? As soon as somebody uploads a new document, as an engineer with my background, it's like, okay, how am I going to QA this? How am I going to make sure that the quality is consistent every time? Because I want to deliver a great user experience to my users. And I want to make sure that every time they're searching, they're getting the right thing back. And it's just not making something up, especially if it's something like an HOA document, which I want it to be accurate a lot of the times, or if I'm doing law documents or something like that. So that's just been a big problem in my space that I've been trying to discover. It's like, okay, so what other solutions are there? Is it just me? I just need to now learn machine learning because I don't have a machine learning background. I just know how to make apps and do those types of experience. So and I've been seeing this kid named Dhravya out there in the mix building this app called Supermemory. And so Dhravya, I'd love to kind of hear from you a little bit about your experience kind of building these types of things and kind of your experience with this and the problems you've been kind of running into as well.
Yes. So originally, when I started off with using vector databases, I started using this thing called ChromaDB. And Chroma was this like huge thing back then because it was like apart from Pinecone, which was the hosted solution, Chroma was the only thing that you could run like on your own like servers or computer. And that's why like it was a very easy way to get in. But like I remember the very first time I used a vector database, I was using it for a law related thing in India, and I fed it with like a million documents, like million chunks. And like it the performance was extremely bad. And I was actually making it for my cousin back then. So my cousin was like, "Oh my God, this is really slow. Can we find out a better way?" So like since then, I have like trying to, find good, like I have looked into every single vector database, including Pinecone, Chroma, Milvus, basically everything you've heard. So after like doing all of that and seeing the cost, so there's three things that always go wrong. One is the cost, scale, or reliability. Uh, like one of them always has to mess up. And that's why to optimize all three of them, I initially went with the cheapest option for me, that is Cloudflare's Vectorize. And it's amazing because it can easily scale to like millions and millions of vectors now. But like a few months ago, it had a hard limit of 200,000 vectors, which was not enough, but enough to get supermemory started. So yeah, so we have moved off of Vectorize now to Postgres, and like that's why we ran into these issues as well. The ones that you just said, like everything from re-ranking to getting the like right stuff as the response to chunking, like everything, and even scaling. How do we do binary quantization? How do we do like IVF? Like PGVector Scale fixed a lot of our stuff when you guys released it. So thanks for that.
That's cool. Yeah, Avthar, I was just going to say, or Matt, feel free to kind of chime in. I was just kind of curious how, you guys have been working on this products for a long time, kind of why you guys came up with this type of solution and like who are these types of things really good for? If I'm tinkering around with this and I'm going to make a serious product in production, would just love to kind of hear more of your thoughts. Yeah.
Yeah, maybe I'll let Matt start off first since he's actually the person that built PGVector Scale, so he knows all about it, and that was really our first breakout product. And then I can come in and talk more about some of the high-level use cases that we're seeing and some of the applications that are actually in production today with PGAI and PGVector Scale. So yeah, Matt, take it away.
Yeah, so we started at building PGVector Scale mainly to allow people to store bigger scales of workloads than PGVector had. So as background, most indexing techniques for vector data, and this is Postgres as well as other technologies, they all require your vector to fit in memory. That's just because of the type of indexing they do. Most of them are graph indexes. And if you think about it, when you're traversing graphs, you're kind of moving around randomly inside of memory. And disks aren't very good at that. So that's why most indexes require you to be memory resident, which is really expensive because memory is expensive. And this work out of Microsoft called DiskNN was really the first large-scale algorithm that allowed you to use disks as well as memory just because of the way it collocates things. And so we saw that, we kind of saw the state of the market, and we're just like, let's build this for Postgres, just because we want to allow Postgres users to take advantage of the scale this provides, right? Along the way, we learned a whole bunch of stuff. As is kind of usual, like this is a very new area, so a lot of things are kind of experimental. To tell you the truth, people don't have a very good, like, fundamental scientific ideas of how these vector indexes should be built. And so we did a lot of modifications actually to DiskNN, but then we were able to provide this index type, which we call streaming DiskNN, to Postgres, and that really allows you to work with millions of vectors in Postgres. I think our benchmark against Pinecone was 50 million. We've done more work since then. So yeah, that was kind of the first step, was just allowing people to store this kind of stuff in. But then I look at kind of the state of the world, and I'm like, fundamentally what a vector is a way to retrieve some other kind of information. You see this with like RAG, you see this with other semantic search applications, right? The vector is just the thing that allows you to search. And so I'm like, in databases, we've known this for a very long time. It's called an index, right? And so why do we have all of this complication of a separate database? Why do we have to take data we have in, let's say, text format in one place and then ingest it into a totally different system? This should all be much easier. And that's really where Vectorizer came from, right? The core idea is to make working with the vector data as easy as creating an index in your database system. And for some technical reasons in Postgres, it can't really be an index per se. But if you look at like all of our commands to set up vectorizers and everything like that, it feels like creating an index. And the core thing that makes it feel like an index is that you ingest data just as a regular text or binary data or what have you, and the system automatically generates and indexes the vectors for you. And as your data changes, the system kind of automatically keeps up with those changes without you having to build all of these kind of complex pipelines, queuing systems. To do this correctly, like at a minimum, you have to set up Kafka if you don't have PGAI Vectorizer. And so that's kind of what we built, is just an easy way of using vectors to kind of index, search, and access your data.
That is so brilliant. So did this insight like seem very obvious to you, or was it like multiple steps to kind of make this discovery? Because for me, sometimes, like they seem very obvious, but no one wants to solve them, or they seem obvious and then they go solve them and they make something that's very proprietary, so they can then profit and so forth. And so I was just kind of wondering what your guys' thought process was in this whole step here.
I mean, it took us a little bit to get to it because, quite frankly, like this idea of making it an index was a little bit obvious, but then it took me some thinking because, as I mentioned, you can't actually make it an index. And the reason you can't make it an index is that what you're actually indexing is part of your data and not your whole data. This is where trunking comes in, right? So you have a long document, you chunk it up into smaller pieces. And this index, what vectors provides, actually um, actually searches through parts of your document. That's not really how databases think about indexes. Indexes are something that retrieve the entire row. So that took a little bit of thinking to see how we can square that circle, because we wanted the feeling of an index, but we couldn't actually make it an index. So that was, I would say, the kind of hardest thing to wrap your mind around in this whole process.
That's excellent. That's excellent.
I think one more thing that I'd add, going back to something that Dhravya mentioned, is I think in the beginning when you're building these RAG systems, or if you're building like a semantic search system, maybe you'll look up some tutorials on how to do it. Maybe you'll ask Claude or ChatGPT for some help, and you'll get to a V1, and that's good enough for some time. But then you realize that like the demands of a quote unquote production AI application, and that just means like, hey, I have real users, even if they're only a handful. That has certain demands that is different from like the initial build and the initial setup. So, for example, in most of these applications, you have to do some sort of data updates where either data becomes outdated or new data gets added to like the knowledge base for RAG. So, for example, like in Supermemory, users might like add or delete notes. We have for example, customers at Timescale who are building like internal enablement chatbots where product functionality changes, and so you need to make sure that those products and those capabilities are the latest in the chatbot. Otherwise, your team is going to be confused and think that the product can do things that it actually can't. And then also, there's other demands around like, hey, OpenAI released a new embedding model. How can I like update all my embeddings to this new embedding model? What does that mean? Oh, I need to run my pipeline again. I need to make sure that I have a graceful migration and migrate over my production table, et cetera, et cetera. And so there's a lot of like all of these. I call them like production demands or production annoyances, to be very honest, where it actually makes it very difficult to to run and to scale this AI application. And I think as Matt said, initially all of this stuff wasn't obvious to us. It was only in trying things ourselves and working with the customers that we have and the users in the community. I think one good thing about the PGAI project is that it's all open source, and so we get a lot of feedback through things like GitHub issues and things like the Discord community, and that made us think about, okay, are these problems like just because some problems are just things that you have to tolerate, like they're part of doing business, it's part of being an engineer. But we thought about like, hey, are these actually problems that we can solve, and are these actually things that engineers would rather not do? And so that led us to a lot of the functionality in PGAI Vectorizer, where taking away the burden of embedding management, embedding syncing, and also some really cool features for things like experimentation and testing rather, where you can like with one SQL query spin up a copy of your data with a new embedding model. You can spin up a copy of your data with new chunking and formatting.
Wow.
And I think one insight that I learned from someone that we work with, Jason Liu, is he said something about your AI application is only as good as the rate of your experimentation, because I think you can never build a perfect application first time, and as your users are using it, as the technology changes, for example, new models, both embedding and like LLMs, you are bottlenecked by how fast you can improve the application. And so a lot of what we were thinking is like, okay, how can we not just make it easy to get started, but make something that allows developers to improve their application quickly? Because ultimately, that's what you're trying to do. You're trying to build the best app. You're trying to make your users happy. And so that's kind of some of the thinking behind it. And, hopefully that shines through in the product.
Wow, that's cool. Is it here that you have a slide kind of talking about this that we kind of want to pull up? Is that kind of show some of the
let's do
architectures
it.
that
Yeah, let's do it. Yeah. If you want to go to that screen. Yeah.
Cool.
So here's like an overview, and I'll take you through kind of how we're thinking about it. So in many vector database systems, you just have your ability to store your vectors and your metadata. So often what that means is that you're going to have embeddings and you're going to have some sort of metadata attached to it. So if you just like, let's ignore like this part of the screen for a little bit, even though I just highlighted it, and just like focus on this part. So without PGAI Vectorizer and without like the regular way of doing things, you just have your source data and you have your embeddings, and you have to have all this pipelines and plumbing and queuing systems in order to update them and create them, and then also make sure that they're in sync. And then, now we're storing source data and embeddings in the same database because it's Postgres, but some vector databases have these limitations. For example, I don't generally like to talk down about other, I think a lot of people are doing good work, but we've heard stories about limitations in things like Pinecone, things like Chroma, where you have constraints in the metadata that can be stored there. So you end up having these like multiple systems that you're managing. And so what we decided to do is said, okay, let's do two things. Let's, one, allow you to keep your vectors and your source data in the same system, in the same database. And so we have this source data table, and then we have this like embeddings table. But then we also asked ourselves, okay, how can we have a system to keep everything in check? But we don't necessarily want the compute burden of embedding creation in order to be in the database, because that's something that we heard concerns about, where it's like, hey, if you have a production database, you want it to serve your users, you want it to serve their queries, you don't want to be have degraded performance from the fact that you have like embedding models running on the same system. And so that leads us to this kind of like two component system, where you have a database where the majority of the action happens, and then you have a worker, which is where the actual embedding creation and chunking and splitting happens. And so the good news is that what happens is that the interactions between these two components are actually organized and like mediated by the database. So for example, you have your source data table. What happens is that you also define your configuration, which is like, hey, what is my embedding model that I'm going to be using? What is my chunking? And then what happens is whenever data is like added or modified in the table, there's a database trigger, and then that gets added to a work queue. And then this worker does like 5 things. It like first checks for new work in the work queue. It reads this configuration from the storage to say like, okay, I have a new row, like how do I chunk and format it? And then it does the actual chunking and formatting. And then it sends the text. It sends the text to the embedding service, in which case, right now, the system PGAI Vectorizer only supports OpenAI. We're actually adding Ollama support very soon. I know that was something a lot of people use, the open source models from Ollama. And so it sends it out to this embedding service, and then finally, it gets back the embedding, and then it writes it in this embeddings table. And so all of this actually happens under the hood. And all you need to worry about is like, hey, am I like adding the right source data to the source data table? And am I like querying my embeddings in my like similarity search and in my RAG queries? Everything else kind of gets taken care of under the hood. And this is kind of the key insights. And like, it's I hesitate to even call this an architecture diagram, because it's like very simple, but this is just kind of a helpful diagram to see like what's going on.
Wow. That's really, really interesting and very, very cool as far as like kind of laying out all the different pieces here, because there's a lot of moving pieces. There's a lot of different words, especially someone who's kind of new to building, to kind of think about how their data is coming in and coming through these different flows, and how it will get transformed for an actual user experience and stuff. So yeah, I kind of wanted to like also kind of bring it back to Dhravya as well, because The whole like our like I literally just sent him a text of that tweet that you sent about the the whole thing about the vector databases are the wrong abstraction, and that just kind of got me thinking. It's like, yo, am I on the right track? And it's like, Dhravya, like, what are you working on? How are you handling this with Supermemory? Because you also said you recently started using the Cloudflare embeddings, and so as an engineer, I'm just trying to figure out, okay, I want to make sure that as a single person engineer, I don't get into the wrong stack and then just kind of have to back out lots of work, or my goal is not to hire a bunch of people. I try to keep things as simple as possible. And so just kind of would want to hear a little bit of your experience here, Dhravya, and kind of, you probably read this tweet and you're reading all these blogs and stuff, and kind of any insight that you can share about your products.
Yeah, so um, right now, like before this, what we did was that we had a queue basically, and in the queue we had like when the user creates something, like there's this entire set of events that happen, including the chunking, retrieval of data, and then actually putting it in like the vector database and then putting it in the actual database. So that entire thing was like hard to manage for us. So I like the adding part of it. But retrieval for us was like quite it was quite simple. In fact, we never had to touch our actual database when retrieving. We literally just used to hit our vector database. And then we stored like a very small metadata of like where it is. So that kind of worked for us. I have a question for like Avthar and like Matt about so in your case as well, we have like I really like the way addition of data is simplified, and like how everything is happening in a background worker and stuff like that. But like it would be very interesting to know if it's possible for me to have like a normal retrieval pipeline with this adding pipeline.
Maybe say more. Oh, yeah, go ahead, Matt.
So by retrieval, you mean searching the vectors, right?
Yes. Yes.
Yeah. So after, if you get that slide back up, after the creation pipeline is done, your vectors actually end up in the embedding table. And that embedding table looks like any other table with a PGVector and vectors in that table. So your retrieval doesn't have to change at all. The only thing we add on top of that is we actually have a view, a database view you could use in addition to that, that joins the vector data and the original source data. And that's just a convenience feature. So if you, once you find the 10 or whatever top K most similar vectors, you could actually then go back and get all of the information that you had in the original row that vector came from, right? So that
Right.
opens up a whole other world of possibility of what you can do once that data is retrieved. But
Yeah.
yes,
Actually,
other than that, you can query it the same way you would any other. Yeah.
so that's cool. So you can basically use PGAI and PGVector Scale at the same time. So you can use like IVF and quantization and all of that
Correct.
along with.
In
That's cool.
fact, one of
That's
one
cool.
of the cool things that we do.
Actually,
Oh, go ahead. Yeah, go ahead.
I was gonna say it's not that you can; it's that you have to. PGAI actually depends on PGVector. So yeah, we're building on top of that stack, if you would.
Yeah. That's actually one thing to say as well, is like a lot of the time, and I think this is partly because AI moves so quickly and there's so many new tools getting released like every week. A lot of the time when people see things like in the vector database space, they think it's like, hey, this is a replacement for something that's out there. For example, like PGVector is a really popular project. And people think like, hey, is this a replacement for PGVector? And the answer is actually, the cool thing about open source is that you can build on top of other people's work. And so what we've been doing is to say, okay, if PGVector is very popular, how can we actually build on top of it so that if folks adopt Postgres and adopt PGVector, they can use this really seamlessly and they don't have to change a million things in order to adopt it. And so as Matt said, the embeddings that are created, when they're inserted into the database, we use the PGVector format so that you can easily query them and search over them. And then also, speaking of indices and stuff like that, we're in one of the versions of Vectorizer, there's like an automatic index that can be created once your table reaches a certain size, and that will be the indices that are available in PGVector. It's IVF flat, it's HNSW, but also the
Right.
ones in PGVector Scale, which is streaming disk NN. So
Mhm.
we try and like make all these components work together, and I think that is kind of a key principle in what we're trying to do, and also from a developer perspective, like working with the existing stuff that you already use. I think that's like really important, because you don't want to, like, if you find this new tool, you get really excited and then you realize, actually, like, I can't really, I have to change a bunch of things. You kind of lose momentum and you kind of forget about it. And we were like, hey, we don't want that to happen. And so that informed, a lot of what we built.
Yeah, I actually like that. And so for me to switch to PGAI, all it takes is like the one Postgres query, right? So this is the new question that I have basically for new developers to get onto it. Um, like uh, most people use like database ORMs like Drizzle, Prisma, stuff like that, right? Keysly. So if you do use ORMs, like a format like this where you just write Postgres gets really hard to maintain and scale. Because for example, I need different type of chunkers for different types of like data. And like writing all that code inside the Postgres database like seems a lot of work, especially for someone who already has like a lot of JavaScript stuff written and have it like a very good format of doing stuff. So how do you think that particular thing can be addressed, where like moving in a like different type of language or a different data structure, you have to use like Postgres again?
Yeah, Matt, I don't know if you want to take this.
Yeah,
We have some.
I can.
Go ahead. Yeah.
Yeah, I can do that. So the interesting part is that our trunking and formatting functions are actually already written in Python. They're not written in any Postgres language, and so that means that if you have another trunking method or another embedding method, you can write it in Python and contribute it to PGAI, but we are also actually planning it. It's not out yet, but the plan is that you will be able to, when you configure your vectorizer, you'll be able to provide Python code to like custom Python code to do your chunking, your formatting, and your embedding. So that's kind of like we're not yet there to support JavaScript, but at least if you're a Python developer, you can you can use us and you can use your own Python code.
That's very
Yeah.
cool. Very excited for that.
That's
One
right.
thing I'll add as well is a lot of these ORMs, they provide the options to just execute like an arbitrary SQL query. So right now, that's the way to access it. But in the future, we have integrations, or a couple of folks focus on integrations, and I think it's tough to support everything on day one. And so stuff like this is awesome feedback for us. Let us know like what kind of ORMs or what kind of tools you use that you'd want to make it easier to use PGAI and PGI Vectorizer with. We currently have like SQL Alchemy on our list. I think for JavaScript, that one of the top ones is Prisma, I think. So if there's more tools, we'd love to hear about it. And, over the next weeks and months, try and make it easier to access, maybe by building some wrapper functions and stuff like that. So that, if you're not comfortable with SQL, you can just use it via the ORM.
Yeah, I think lately JavaScript world has switched mostly over to Drizzle ORM. Like that's the most loved, I think, right now. So yeah, that's like my feedback.
That's cool. And Dhravya, like what else? I know because that's a big problem too. It's like, yeah, how do you rewrite these types of things? And then as far as like maybe kind of stepping it back just a little bit more high level, like why should one maybe choose, this platform over some existing thing that's already, out there that's, from a competitor or something like that. Or like the things that everyone's kind of promoting, like I see, Pinecone and these types of things. It's like, oh, cool, I can get started in a couple different steps. Like it kind of give me the opposite case there that, why would those even be a good fit for them?
Yeah,
Yeah.
I
Go ahead.
think like there's like right now how we update is also manual. So like basically where there's update, like we also update the vectors, and that kind of works for us because everything happens in a queue anyways. So like for us that's completely fine. But I understand why someone would use this because usually people want everything to be like lately the at least JavaScript world has been moving from the separation of concerns paradigm to everything being in one place paradigm like Next.js basically. And so like PGAI kind of helps with that because then you have like most of the concern inside the like Postgres layer itself, and then the database kind of handles everything. I personally, I think for our own project, it's like too much rewrite to move to it right now. So like right now, it doesn't make sense for us because we have the entire pipeline ready. Unless it speeds everything up, which I'm interested about the benchmarks and stuff. Um, like we already like I like to write JavaScript and I'm better at JavaScript, so I keep doing that.
That makes sense. We have one question from a user here that says basically, how does PGAI handle updated data? Is there a reindex of embeddings or all embeddings flushed and re-embedded? Is this something that I think you have a demo of Avthar? Avthar?
Yeah, we can get into the demo, but I
Okay.
think for this specific question,
Yeah.
maybe Matt, you want to give an answer? I think it's just about like as like the source data gets updated, how do we kind of handle that today?
Yeah, so as we mentioned, there's a database trigger that puts the change that puts pretty much a pointer to the change the row into a work queue, and then the worker will automatically read that work queue, read the original row, re-embed it, and then write the new version of the embedding into the database. So it's not like you're re-embedding the entire table, but you do have to re-embed the rows that have changed.
Yeah, and in terms of the index, in most most of the indices in PGVector, like HNSW and the one in PGVector Scale, streaming disk NN, if you update an embedding, you don't have to recreate the index. Like that will get handled, and you can just keep using it. So you don't have to re-index the embedding, but it will get updated in the index, if that makes sense. And that all happens transparently. There's no kind of work required from the developer perspective.
Oh, cool. Awesome.
Yeah.
And so I think we probably were going to get into a little bit of a demo here with your project here. Yeah.
Fantastic. Yeah, I just, a lot of the stuff that we've been talking about has been pretty abstract. So I thought maybe it's just a good idea to get a sense of like, hey, how does this work? And maybe let's see it on a sample data set. So what I'm basically doing is I'm going to follow this tutorial. It's in the PGAI GitHub repo. So you saw I just literally went to the docs folder, and it's this file called quickstart.md. And so we're going to go through it, but I've done some of the steps already. So for example, let me see if I can show you. So what I have right now is, is this sample Docker Compose file. So coming back to what we talked about in the diagram, there's kind of two services that you have. You have your database service, and then you have your external worker. And what we're doing in this Docker Compose file is just setting these up. And then if you do this for real, you obviously replace this by adding your OpenAI API key. which is what you use to create embeddings and what the system uses to create embeddings. So that's kind of the setup. I've already set up at least the database part, and we're going to do the external worker in a second. But let's take a look at the data that we're going to use. And sorry, I've got a lot of different desktops here. So let's take a look at, I've created this table. It's called blogs. So let's just take a look at like what data is inside here. And so I have this table. It's actually blogs from Sam Altman. So let's take a look. You can see like there's a blog called GPT-4o. There's a lot of sentences. These are like full blog posts, and then I also have a URL for the blog. And you can see there's I've only done 4 of them just because this is a small demo, but you can extrapolate this to tens of thousands, hundreds of thousands of rows. And you can see that these blogs are quite long, so they might not fit in a single embedding, and so you need to do some chunking in order to create embeddings, and we're going to see how the system handles that. But at a high level, we have the blog title, the content, and then a URL, and we're going to see how all of these are going to be used in just a second. So what's needed is to first, what we're going to do, let me navigate to this demo file, is we've created the embeddings, we've created the table to store the blog. So that's what I've showed you. We've inserted this data. This is kind of where the magic happens. So this is this create vectorizer statement. And what you do in order to, this is the first step in order to automatically create an update embedding. So you can see right now I have a table with data, and I need embeddings. So let's get some embeddings, and then we're going to do semantic search. We're going to do some RAG on them. So what we're going to do is let's execute this so that it actually runs while I'm talking. Let's go back here. There we go. I'm using this Postgres, what is it called? Postgres editor and visualization tool called Popsicle, because it's a bit easier than just looking at the terminal. It also displays the rows quite nicely. So we're going to do that. So let's run this. And then, okay, I see the issue here. Let me actually, this always happens live. So this is good for a live demo.
It's
we
authentic.
Actually need to, yeah, exactly. This is like literally what you would have to do. So let me actually install the AI extension. Let's go back to Popsicle. Okay, so what we're going to do is install this the Postgres extension. So the way that PGAI is implemented is a lot of the logic for the embedding, like the queue table and the configuration and stuff like that, is handled by this extension. It's called AI, and this will actually automatically install PGVector as well. And so that's why we use this cascade command. So let's try that other command again to create the vectorizer. And then we're going to see how that runs. Okay, so the vectorizer is created. What I'm going to do as well is go to my terminal, and I'm going to start the vectorizer worker. So this is Docker compose up. This is it here. And then I'm also going to let's just look at the logs of the worker. And so you can see actually, hey, this worker has been created and it's actually running right now. So while that runs, let's go and take a look at like, what did we do when we created a vectorizer? And then we'll come back and see the embeddings being created and what else is created that Matt actually talked about. So in order to create a vectorizer, you just need to define the table that it's going to be run on. So in this case, we created a table called blogs. It's going to vectorize and embed all the data in that table. You need to choose your embedding model. So here we choose the text embedding 3 small model from OpenAI, and that's going to be the model that is used to embed the data. And going back to the diagram that I showed earlier, that's really where we make API calls to OpenAI that happens in the external worker. Then, as we saw that this data is actually, it's quite long. You need to chunk it, you need to split it. And we provide some out-of-the-box functions for this. This is like simple recursive character text splitters. And then you define the column that you want this on. So in this case, I have my data in the content column. And so I'm going to define content here as a column. And then one of the coolest features is that it makes it super easy to add like additional context from other columns in your database. So you can see I have a URL column, I have a title column. a lot of splitting today just takes like the chunk of data and it just splits it. But what we're going to do here is actually define a string that says like, hey, this is the format of the data that I want it to be in. And so I want to have the blog title and then put the title from the title column. I want to have the URL, put the blog URL, and then I want to have the blog chunk so that I don't lose. So for example, I know that when I get it back in search, I know that, hey, this is the blog title it came from, this is the URL it came from. If I didn't have to kind of query that and then join it, again, you just get it back one time. Okay, so now that this is, hopefully the embeddings are created by now, let's take a look at what actually went on in our database. So you can see here, I have 2 tables created. So I have this blogs table, and then automatically, like I didn't create this table, I now have this table called embedding, blogs embedding store. So this is actually the home for the embeddings. And then I have this really handy view that Matt talked about, which is called blogs underscore embeddings. And let's just do a select all actually. Blogs underscore embedding. So we're going to take a look at this table. And this is actually a join of the original blogs table with the embeddings table here. And so if I look at a specific row, I can see the embedding ID, I can see the chunk, and then look, remember I talked about the formatting and stuff like that. You can see it's not just the text data that it's in here, but I have the blog title, I have the URL, and then I have the blog chunk. So this stuff that I defined here is actually being respected by the Vectorizer. And then you have the actual embedding. So let's just a list of numbers. This is from OpenAI. And then if I want to, I can actually get additional metadata. Now, for this simple example, I actually put the metadata in the embedding. But if you think about Dhravya's kind of application, you might want to store things like, oh, when is this note last updated? Are there any tags about this note, or things like that? So this could be 5 or 10 other fields that are associated with it, and it makes it really easy to query these all at once. Another thing I'll note is that you can see here I have 15 embeddings created, but I only had 4 blog posts. And so this shows you that all the chunking and all the splitting is taken care of. And while we're on the topic of chunking and splitting, it can actually get quite advanced where you can chunk different kinds of file formats, and we make it really easy for you to not just you can obviously stick with the default, but for example, let's say if you have HTML websites, HTML files or something like that, you can define custom separators so that it appropriately chunks that kind of data. And you can think about the same for markdown files if you're building a documentation application or something like that. So I'm showing you the easy mode. You can kind of customize this and make it as relevant to your use case as you want. So, okay, so we just saw, embeddings that were created. And, again, this is for every single blog post. For each chunk that happened, I now have embeddings. And once again, I didn't make the API calls myself. All I did was provide my API key, and now I have embeddings. But embeddings are only as good as what you use them for. And so let's do a small semantic search query. And once again, Dhravya was talking about we had this idea of hey, making it compatible with PGVector. Once again, this is the PGVector operator for similarity search. And then, thanks to PGAI, let me just run this and we can look at the results in a second. Thanks to PGAI, I don't have to create the query embedding in my application code. I can actually create it in the database thanks to this OpenAI embed function. And then again, I'm just saying hey, give me all the embeddings related to generative AI models. And you'd expect to see embeddings that are from the blogs about generative AI. So you can see here, the blogs about GPT-4o, the blogs about DALL-E 2, etc. And so that's kind of an overview of the PGAI vectorizer system. One more fun thing that we can do is let's just take a look at how you would do RAG. Once again, this would be in your application, but for the sake of this demo, I'm just going to do it in the database. So I have this function. Sorry, this is going to go fast, but I promise I'll explain it in a second. So I have this function that what it's going to essentially do is say, hey, take the chunk that I get from the similarity search, and then make a call to OpenAI GPT-4o Mini, and you can customize the prompt. It just says, hey, you're a helpful assistant. Use only the content context provided to answer the question that the user asks, and then also mention your like source material, so like the citing your sources functionality, which is often really desirable. So that's a function that I defined, and then let me run this, and then I have this question, which is like, what does Sam Altman think about generative AI models? And we're going to answer it just based on the content of his blog. So let's have that run. That's most of the latency is in the OpenAI API. And you can say, hey, Sam Altman, he has a positive view. Surprise, surprise. He believes, these things. And then it shows you, hey, these are the references from the model. It shows you the blog title and the link. And this is all from the data that's in our database. So once again, making it really easy, like once you have data to create embeddings, and then as the embeddings get added and changed, the system will automatically kind of keep up with this. So that's PGAI Vectorizer. And then one last thing I'll mention, I talked a little bit about testing and experimentation. So the final thing I'll say is, like, for example, you can create like different versions of your data with different embedding models just in a single SQL query. So like you saw how I use the text embedding 3 small model. If you want to create a version with the new text embedding 3 large model and you want to use a different dimension or something like that, this should probably be 2000 for it to work. You just have to run the SQL query, and then all the embeddings get created in the background for you. And the only thing you have to define is what's called this destination table, which is the name of the view that you're going to be querying, so that you can actually understand, like, hey, which table has which version of my embeddings. And then the same is true for different kinds of chunking. So let's say I want to try different chunk sizes, different chunk overlaps. I don't have to go and run this myself in my pipeline. I can just have the vectorizer create this for me, and I can experiment and try all kinds of different things. Maybe I want to try and add different like metadata and stuff like that. So that's an overview, some of the stuff that I talked about testing and experimentation.
Wow.
And hopefully that gives you a sense of, all the stuff we were talking about. It's just SQL. It's like, it's hopefully super simple, and making it easy to get started and to improve these kinds of RAG and such
How
systems.
is the performance? Because Dhravya, I just would love to hear some of your experience. Like, how many records, Dhravya, do you have like in your app? Because I know your app's grown really big now with as the users scale and keep growing. Do you have any idea? Because I'm curious, like, if you wanted to try a new embedding model, kind of what does that look like for you?
Yes. So if I switch over an embedding model, it will automatically update like 2.5 million rows, which would be devastating to my bank. So I just cannot do that. So I have multiple questions here. First of all, like, how does the observability look like in this case? Because secondly, wouldn't it be cool if it can also handle the chat threads and chat history and stuff like that? And wouldn't that mean that you can basically make like an entire like system, like entire like everything you need with RAG inside Postgres itself? Because in the end, you are kind of like storing the chat history, right, in Postgres. That would be pretty cool. And thirdly, like, yes, like, how does the performance look like for growing applications? Like, I know it's obvious that if you change every single like embedding in the database, that will be a mess. But even other than that, like, like, is there any benefit to putting everything in Postgres, like, from an infrastructure or a performance wise?
Yeah, Matt, why don't you take this since I've been talking a lot?
This is I mean, to tell you the truth, this is a kind of a deep and complex topic, and you can kind of see from our own architecture that we don't believe everything belongs in the database, which is kind of why we have a split between like the part of the vectorizer that's inside the database plus the worker that's an outside Python application that actually does the thing. So I'll say a few things. I think it's very useful for people getting started to be able to do a lot of these things inside the database. It makes that loop super fast. And as as you grow your application, the thing is we are not like, we're opinionated, but we don't dictate to you what you must do. So as you grow, for example, Avthar showed that you can also generate the embedding for the similarity search inside the database. And when you're starting up, that's a perfectly fine thing to do, right? But
Right.
once you grow up, you might want to move that into some kind of into your web service, right? And that's totally
Right.
fine. You can do that, and just pass in the vector inside of the string. So whenever
Right.
we design when we design the entire system, the way I always thought about it is we need to make it super simple to get started, but not have scalability. Like, you can hit a wall where we don't support you anymore
Mm-hmm.
because of scalability challenges. We always try to give you a way to move things into different components to grow and evolve your system so that you can handle large scale. So in terms of the scale, on the embedding system itself in PGVectorizer, we haven't done like really very thorough benchmarks, but in our cloud environment, and this is available on Timescale Cloud, we've done some preliminary testing just to make sure that we don't mess anything up, and we see that we can create about 300 chunks a second without, we can embed 300 chunks a second and process that end to end, from reading it to embedding it to putting it back into the database. And that is without a whole lot of performance optimizations. So we believe we could grow that probably an order of magnitude or two, but like for most of the users we see today, embedding 300 chunks is way more than enough, right? And
Yeah.
in terms of indexing, like the index performance is the same as either PGVector HNSW or PGVector Scale's streaming disk, and we don't change anything there. So the performance you'll see on the search will be the same as without Vectorizer as well.
Right.
Does that
And
answer
the
your
second,
questions?
yeah, yeah, it does. Like, I totally understand. Like, I think the real problem comes with us putting the embeddings creation also in the pipeline, like because the embeddings creation is not something that we are doing, right? Like that's an external service. And that's kind of what's slowing it down. So, the other question was that like, how does the observability look like in like, how do you even do all that stuff? Because how do you see how much it's taking to embed stuff? How like how long it's taking to store it? How long it's taking to like query without like all of that stuff?
Yeah.
Because the pipeline is pretty big
Yeah.
and because it's abstracted away, it's hard to like know as a developer like what you're getting and what you're not, right?
Yeah, so this is, I'll be very honest, this is a thing we are still working on. After, you could show, I don't know if you have in your code, the view
Yeah.
of the vectorizer status. That could be
Yeah.
useful. So we have a view which tells you which vectorizers you have and how much is left to embed, which is like kind of a very simple thing you need, right?
Yeah.
Yeah.
So yeah, the key thing is the pending. What do we call that column?
Pending
Pending
items. Yeah.
something good. Pending items.
Pending items.
Once that's zero, that means all of your stuff has already been embedded, and that will obviously completely change when you update stuff. When you insert more rows, you'll kind of get more pending items in that list. And so the basic observability of, is everything up to date is kind of very easy through that column. You could imagine putting a Prometheus kind of exporter thing, which would monitor that column, and that would tell you how fast the embeddings have happened in the past. But we do plan on making that simpler. And again, on the read side, on the query side, you could use any of the tools that already exist for monitoring Postgres queries.
Like PG stat statements and stuff like that.
Yeah, it could be PG stat statements. You could use explain plans. You could use, again, the Prometheus exporter. That whole ecosystem is just available for you out of the box, right?
Right. Sorry, I'm like bombarding with a lot of questions. And like I had one
I
small
love it.
question, like for updating a row, right? Like, do you just update it with a like normal SQL, or do you need to do like a specialized query?
No. I think that's the beauty of it. On the source data, all you do is regular inserts, updates, and deletes,
Okay,
and
that's good.
everything happens kind of automatically under the hood using database triggers, which we create, which you don't need to worry about. Yeah.
Right. Very cool.
One thing I'm just trying to pull up on a different screen to show you. Let me see if this works. Okay. Let me. Sorry, I'm just doing it on a different screen because it's
I see. Yeah.
just in case I reveal
Okay,
my
I'll
password
just-
or something like
No,
that.
no. I'm gonna keep it for here.
Okay,
Let me
cool.
know when you're ready, and I'll just kind of switch it over.
Yeah. No, we can continue. What I want to try and show is we have some. Let's see, maybe if I can try this service. Okay, cool. Yeah, you can switch over now.
Okay.
Okay, cool. So this
Make it
is
just a little bit
this is a
bigger so
cloud
we can see.
hosted. Sorry, go ahead.
Increase the font just a little bit more.
Yeah, let me do that right now. Okay, cool.
Okay, cool.
So this is so Timescale has this like managed database platform. So what I'm showing you is just it's inside this, so it's different from the demo that I just showed, which is all via Docker and it's all open source. But one sort of thing that we're gonna make it very easy to see these sorts of things is we have a view in the cloud product that shows all your vectorizers that you're running. And you can see kind of, you talked about some observability things. You can see like, hey, the status, the pending items, the last call status. And then we also provide you with a bunch of stuff. For example, you can see, hey, this is the running time of the vectorizer. It's like 3 seconds that it took to run. This is when it was last run at, etc. And then you can also see the configuration once again. And then if we scroll down, let's see. So there's a bunch of configuration stuff. And then this is a successful run. But if this is not successful, you actually get the logs of what went wrong. And so maybe like an easy example is maybe your OpenAI API key was actually deleted from your OpenAI account because your teammate, like, I don't know, messed it up and it got deleted or something like that. And so you'll find that out here saying like, hey, the API key is actually outdated. Check your API key because that's causing your embedding creation to fail. So that's kind of a view of like what we're going to move towards. And as Matt said, a lot of the stuff is work in progress, and we're definitely going to have improvements out very soon. So yeah, I really appreciate the suggestions. I love how you think about it, and I think this is what's really cool about having Dhravya on the stream is just getting that perspective of like someone who's running an AI application in production. That's always cool, and like I'm certainly learning a lot. So thanks so much for that.
Yeah. It's really fun to see like that, and also get any more comments and stuff. And yeah, Dhravya, just keep it coming as far as any questions. I know you have your audience also has questions, and also folks in the crowd. If you have any questions, just let us know, and we'll feature you. It's pretty fun to see Joshua coming here. So wow, these guys are cooking for real. It's like I'm literally just kind of here hosting people and having this discussion because I feel like. Like I said earlier, is the fact that I'm just getting started with a lot of this AI stuff and tinkering around and playing around with projects, especially with like chat with PDF is kind of fun, and that's a really good intro to understand, the basics of these types of things. I come at it from a product perspective, product engineering and kind of understanding, what type of experiences can I deliver. But also having my engineering hat on, I'm like, okay, what gotcha is going to really get me here? Am I going to make a move that's going to like really cost me down the line that I should have probably done earlier? Because I'm really just kind of short on resources. And so Dhravya is already like a bunch of steps ahead of me on that front for those who are just kind of tuning in. And then we have Avthar and Matt from PGAI, Timescale DB, basically, talking to us about like alternatives and different methods that we can use compared to traditional vector databases. So like this, I guess kind of the four main features that I take away from this is just about, sync management, infrastructure, scaling, and like development speed. So in traditional vector databases, you'll have like manual pipelines that you'll have to define for these types of things, where it sounds like in PGVector.ai or PGAI Vectorizer is basically automatic. From an infrastructure standpoint, you'll have like multiple systems with traditional databases or traditional vector databases, where here it's like a single Postgres instance, and then kind of leaving you on your own for these other types of things that you want to manage with your, depending on your tasks, that kind of type of thing. And then from the scaling, you'll have like some complex scaling, which sounds interesting when you have traditional vector databases, and there's different companies out there that try to handle that on you for you on your behalf. It can be costly. It could not be, just depending on the problems you're solving. So with PGAI, it sounds like it's like native database scaling, and then the development speed when you're dealing with multiple APIs versus like a single SQL inference. And so just kind of with that perspective, and the folks who have just been kind of joining in on the stream, we've been kind of talking through some of these use cases. And so Dhravya is basically a cracked 19-year-old prodigy here. Used to work at Cloudflare and had lots of experience building AI apps, and Supermemory is kind of the biggest one that I've seen, which allows you to take your bookmarks, from Twitter and all these, even just life in general. You can put them into the app, and it basically does this, RAG type system, so you can actually ask questions. So I actually had a live stream when you first launched your product on Product Hunt, which was really cool, and it literally just searched hundreds of my bookmarks, and then we're able to find some obscure financial stuff that I was tracking, in my own types of things. So that was amazing, the very beginnings of that type of things. And since then, you've learned so much, and kind of, I would love to learn, we still have a little bit of time, and would love for you to kind of share some of those learnings with our audience, and kind of, what you're thinking here, in front of these guys, and what are your thoughts as far as like, some of the stuff that we've learned today, but like, you've already talked about some of the issues, and any type of learnings would be super helpful just for all of us who are just tuning in.
Yeah, I have learnings and I also have some questions, some more of them. So like I, what I learned is like deleting indexes and like keeping track of indexes has been very hard, right? Like, and writing a lot of pipelines and stuff like that is like too much work for like a small team of developers to do. So in that case, like it completely makes sense to like have it all in the database layer and literally just work with the database, and that's really exciting. Like all you need to do is like put this one function in the database, and that's it. Like your entire thing is done. So my questions like first of all, like is streaming supported when asking a question with the generate RAG function that you gave a demo of? And secondly, for PG vector scale, because we are doing quantization and indexing and all of that, like how is the recall affected there? Like, is there still a like reasonably good recall, or is it like heavily affected?
Yeah, I can take that. So, I think streaming is one of those things that you actually don't want to put into the database. Certainly, we haven't figured out how to do it, but more fundamentally, I don't think it's the right. Once you get into streaming, you really want to move that kind of logic um, into like either Python or JavaScript. It's just a better fit for that. But of course, you will still use the database for retrieving the right context, and that doesn't require streaming, and you actually can't use streaming there because you have to send the entire context to like OpenAI. So
Hmm.
that's the first thing. So it's kind of one of those things that once you grow up where you need streaming, you move that part of the logic into Python. And your second question was about
It was about recall
I'm
in
sorry.
PGVector Scale.
Oh
Like I
yes.
think because of the fact that we do BQ and
Yeah.
stuff like that.
So I think on the 50 million thing in our Pinecone blog, the
Yeah,
recall was either 99 or 98, 99, I think, right?
yeah,
So
Wow.
it's 99% recall, so it's pretty high. The highest we were able to get on Pinecone on anything that wasn't outrageously expensive was 90. So
Hmm.
I think we're doing pretty well. Um,
yeah,
the other thing to note is that our philosophy in indexing is have small defaults, but allow the user to adjust the defaults as they are. So we give you actually a lot of knobs on how to adjust the recall parameters, both at index build time and at query time. So even for different queries, you could adjust how much to search to get more or less recall.
Right.
That's one of the beauties I think about Postgres is like this ability to go into super user mode and to do these kind of advanced things, and that is that is something we fully support and fully embrace.
Right. That's very cool because like usually, for the viewers, I'll tell you what recall is. So recall is basically when you have indexes in a vector database. What's the difference between running a normal vector search, which is slow, and a vector search with like the indexes? Because then the query is faster, but like the responses are different, and then we basically see how different they are and like what's the recall um like how good the responses are with indexes. And usually when you do quantization, the recall like decreases because you can imagine that if you are literally doing like an XOR between like 0 1 0 1 0 1 instead of literally like floating digits, um like it would be a different answer. So yeah.
yeah. To
And,
build on what,
and
go ahead.
sorry,
You go
I
ahead.
just wanted to add that even in our quantizing, we actually have an internal
Statistical.
re-ranking method that corrects it for the for stuff that you get at.
Yeah, I actually had a question with that too. So I saw like the blog and like statistical binary quantization, I think you guys call it. And in
Correct.
that one, like, do you literally do that after every single index is created? Because wouldn't that be also like expensive? Because you would be changing every single index and every single row, right? Like all embeddings.
Uh, no, that's so when you create the index, you decide whether it's quantized or non-quantized. That's an option during index creation. Uh, but if it's turned on, then everything written to the index itself is only the quantized part. We never write out the full part into the index. Um, but you still have the full vector in your heap. Because remember, I think there's a bit of confusion in the AI world because, like, Pinecone and Chroma call an index the same thing where you actually store the data. But in a relational database like Postgres, these are different things, right? And so in the table or Postgres goes into the heap, uh, you store all of your data. You store the full um, float digits for every dimension. But in our index, we store only the compressed representation. And then during queries, we do most of our search in the compressed representation, but then kind of correct the results at the very end by reading off the full representation.
Oh wow, that's cool. That's very cool. There's a lot of
I see.
questions on in the chat.
Yeah, go
I
ahead
was just about to
and
say that. I see there's
yeah.
like a few questions in the chat. Maybe we can take some of those.
Sure. Which one do you guys want to take though?
Yeah, let me start with. I think Mohammed asked a few questions. So I think one of them that's interesting is, does PGAI Vectorizer support the ability to flag outdated vector embeddings, prompting lifestyle updates for artifacts or models? The answer to that is yes. That's kind of the one of the premises of PGI Vectorizer, where we showed you in when I was looking at the Vectorizer status. It'll actually tell you, hey, for a certain table, if there's work to be done, that status won't be up to date. It would be like pending or something like that, and it'll show you like, hey, there's 50 rows pending, or there's 1,000 rows pending, or something like that. And so, kind of built into the system is a that kind of flagging and things like that. And the goal is to ensure that you don't have stale embeddings where the onus is on you as a developer to go and look and see, oh, I have stale embeddings. What do I have to do? Or I have to go and update them, etc. This all gets taken care of by the Vectorizer system, and you don't have to do anything. As a developer, you just kind of let the system run. There's quite actually some other ones over here. Maybe one for you, Matt. There's a question from Boson Collider. Do PGVector Scale indices do anything special to stay in memory, or is it just Postgres's normal page behavior?
I think to a first approximation, it's the normal Postgres page behavior. We are doing a little bit of prefetching, and Postgres 17 actually has a new capability for better prefetching mechanism that we plan to integrate. PG17 is the kind of latest and greatest, came out only a month ago, so we haven't yet been able to do this. But yeah, like most of it is just using the regular Postgres. I think one of the things that I say is one of the reasons we were able to develop all of these capabilities so fast and much faster than, like, say, Pinecone or Chroma is that all of these facilities like memory management, etc., we could just rely on Postgres to do, right? We didn't have to reinvent the wheel. And I think that's one of the exciting things of this kind of philosophy of development, of building on top of layers of open source technology that's already been developed.
Yeah, there's one other question that I think is most relevant, and then I'm not sure how we're doing for time, so you let us know, Ray.
Cool.
The question is again from Mohammed: how can PGAI facilitate data lineage tracking and artifact management workflows for traceability and compliance-driven projects? It's quite a mouthful. The good news is, one of the key things that the Vectorizer system does is transparency. And so you can see exactly, for a certain vector embedding that is being used, what is the embedding model that it was created using? What is the chunking mechanism? When was it last updated? What is the source data that it got created from? And so this makes it really easy to keep track of, hey, if I'm running, let's say you're running an experiment with like 10 different versions of chunking or formatting or like different dimensions for your vectors or something like that. Now that you can choose the dimensions for your vectors and for certain OpenAI models, it makes it really easy to keep track of all of that. A lot of the time it's just in some like Google Doc somewhere or in someone's like notebook or something like that. Now you actually have a source of truth for that. And I think that can really help in compliance-driven environments. So I think that's kind of how we're approaching it, is just making it really easy to keep track of the different versions of your embeddings. And it doesn't just help for compliance, but for general, like just development and testing. that's the biggest benefit that we see.
I will also add to that we are fully Postgres compliant, so you could add triggers to your tables, your embedding tables, anything like that, because oftentimes they are in the compliance world. They use triggers to do sort of deletes and all of that, and that just works the same way it would work for any other Postgres table.
Cool. And I think Dhravya had some questions.
Yeah, maybe this is just a general Postgres question, but because I'm using Postgres right now, I would love to learn this. What's like the approximate max number of documents that you can store in like a computer with 32 GB RAM, 8 virtual CPUs, like basically the same specs as like a T3 large.
Yeah.
I know it's a very specific question, but what's the maximum you have seen in your customers or in in the world in general?
I'd repeat the RAM and disk specs again.
32 GB RAM and 8 virtual CPUs. And like the disk is like, let's say
You
160
have
TB.
you have like a terabyte of disk. Okay, cool.
Yeah, let's just say that.
I think a lot. I need to see. Let me just look at like what the specs we used for the 50 million embedding test.
Yes.
Let me pull that up, and then Matt, if you want to,
I think
give
that might have been. I think what I can't remember is whether it was 8 or 4 CPUs, but
Yeah, let me double check.
similar specs. Yeah, and just for the record, the 50 million wasn't actually the max. It was just it was hard to get a free data set that's bigger than that. But
that is pretty
Yeah.
amazing
do
because
you have those numbers?
Yeah, I'm trying to look it up. I think here's a deal for how to think about these things. So I think that you're going to be limited by I think the main thing that's going to limit you is not necessarily the CPU, but it's going to be the RAM, because that's kind of where your documents are going to be stored in memory. I think there's a few ways around it. I think the first way is you don't have to keep everything in one big index. You can actually have smaller indices. Let's say, for example, in your application, maybe each user gets their own index, because I don't know if one user is going to query data from another user. That's a practical thing. And so that kind of helps you where it's in practice, you don't have to load a huge index into memory all the time, et cetera, et cetera. Another thing is exactly what you mentioned, this binary quantization and statistical binary quantization. What we found is that that really reduces the index size in memory, such that you can run on these smaller compute and RAM configurations. So I would recommend just playing around with that, because that's going to reduce the size of the index in memory. And then the final thing is coming kind of full circle to why we built PGVector Scale, is you can actually store some of the index on disk. So if you're running on a machine with SSDs, there's ability to do that, so that if you run out of memory, you can actually leverage solid state disks if you don't want to change your machine or something like that. I know, Matt. I'm just talking. Matt is a real expert here. I'm just giving you kind of what I've heard from customers.
I would. By the way, I think it was actually an R6 slot, which is 8 CPU and 64 gigs of memory for 50 million. But again, my expectation would be that you could get away with less. Let me just double check something. Yeah, so it
want to share their
was.
screen or
Yeah.
okay.
I have a very interesting
But
proposition that could make a really good idea.
Let me put that on the screen here.
Is that me? Oh, I'm not sharing anything. Matt is the one.
I'm gonna put it here. Yeah.
Oh, cool. Yeah, go for it. Yeah. Oh, yo.
Yeah.
Okay.
So Okay, so I was just thinking, so right now, I made this like small prototype of like a new type of vector database where you kind of offload, instead of storing everything in disk or memory, you offload the documents to like object storage. And then you kind of evict stuff from the memory as needed. Right. So right now I do that like manually using my namespaces, but it would be extremely cool if something like this can be done using like the Postgres indexes inside the database itself. That would mean that and I know Postgres like Timescale has done this before, like using object storage to increase the like size of Postgres. So have you guys looked into doing that along with vector database? Because I did not see anything that you guys did.
We haven't looked into it much. So actually, already today you could do this with us for archive data, but that the archive data you move off to S3 would be really slow to query. In terms of doing things for like live data, it's something we are looking into. But one of the things that actually concerns us about this is I don't want to like. Okay, I'll just say it. I think like Pinecone serverless and Turbo Puffer are really their serverless offerings, which all flow things to S3, are really geared towards the case where most of the data will be cold most of the time. So it's really for like a multi-tenant use case where
Yes.
only a few tenants are like actually ever querying the data. And so
Yes.
even if you look at their pricing models, by the way, like storage is cheap, queries are extremely expensive. Like
Yes.
try to like get a price for even one query per second. It's gonna be expensive. Um, and so if I'm honest, like I don't think our primary use case is this kind of multi-tenant use case uh, where most of the tenants are completely cold. I think our primary use case is going to be like an operational workload used very actively by applications. And so I don't think like S3 compatibility is on our immediate roadmap because fundamentally I don't think S3 can really do well with those kind of workloads.
Yes,
Because
I
just
agree.
if
So
you yeah,
like from an advice point of view, do you think supermemory is like a good multi-tenant workflow where like half of the user data is stale? Because like let's say I have 30,000 users, but only 8,000 of them will ever visit the website in the week. So in this use case, maybe it's helpful.
maybe, although I would say that 8,000 out of the 32,000 is actually not what I was thinking. I think like when I think of a multi-tenant use case of this kind of thing is like it would be like 200 out of 32,000, which I think a lot
Oh
of
wow.
people have that, right? I think if you're like Google Drive or like even Notion, like the majority of Notion people are not going to be using uh, the AI features most of the time. I think like you're going to have a very Zipf-ian distribution.
Yeah.
Is my feeling because that actually, like, if you look at the internet in general, is all of these kind of like heavy tail distributions where most people, there are very few people actually causing most of the traffic, and I think you'll see the same thing here. But for super memory, I think you might not quite have that distribution. So something, if I
Right,
were you, I would really carefully look at the distribution and just price it all out, because there's
right.
no way to know until you do that.
That's true. Yeah, that makes a lot of sense.
Wow, that's super handy. That's cool. I think there's a couple questions in the chat. I haven't really been kind of catching up with it. Is there anything that you see, Avthar, that we can answer?
Yeah, there's some that may be a bit too niche for maybe the general audience. Um, I guess I actually had a question for Dhravya, just to turn the tables a little bit.
Let's go.
I'm actually curious in building this application. I'm curious about, like, if you had to give advice for how to choose a vector database or a database. You mentioned you went from this journey of, hey, you started off with Chroma, and then you went to Cloudflare, I think it was, and then now you're on Postgres. Can you talk about, like, the pros and cons that you saw? Because I think a lot of folks that I've spoken to, they're trying to put together like a checklist or a criteria. And so it's great to see, from your experience, what the pros and cons of these systems you found are, and why you settled on Postgres at the end of the day.
Yes. Okay. So let's start with like my own adoption, kind of like the cycle. So yesterday I was at Chroma office. So like I also learned more about Chroma and what they're doing. But like the current option, like that is, the open source version that is there currently, that self-hosted version. They are going to release the cloud version soon, but the self-hosted version costs about $60 like of compute to store an average of like 1.7 million documents. And that is a lot, right? But the query speeds are really good. Like 99% of the queries take less than 50 milliseconds. But that's if you have the embeddings already generated. So that is pretty good, but it takes more compute. um then comes the already. So I was like, okay, let's look for something that's already hosted. So for that there's something called Milvus and Zealous Cloud. So Milvus is also an amazing vector database, and they have like some incredible benchmarks. I will just actually read through them right now. So on the same amount of compute, they can do like 6,000 queries per second, which is absolutely incredible. And like their recall is also like pretty good, honestly. Um, but again, like there's a max of about 5 million vectors, after which it starts getting slow. Um, the same is with other distributed options and serverless options like Cloudflare Vectorize, where I found the same thing. And like that also introduces me to a lot of other patterns. Like, first of all, like the amount of filters available in Cloudflare Vectorize are very limited. So if you want to do advanced filtering, you cannot do that. You can only do like equal to and not equal to as of right now. And I think they added more recently, but like the more filters you add, the slower the query gets. Apart from that, just a few months ago, they had a max of 200,000 vectors, and now they have a max of 5 million vectors. And they kind of do something similar to what Turbo Buffer does, which is like offloading a lot of the stuff to the cloud. So there's like a huge difference in latency for cold and warm data, basically. But because they are the platform themselves, and like they can, it's like co-located because the objects are stored right besides the compute. It's pretty fast for them, so they can do that. Um, then comes the other like cloud options, like of course Turbo Buffer itself, which is absolutely incredible. And I think that there's like no complaints about Turbo Buffer, except you need to have high scale to really get the benefits out of it. You can get the same benefits in Postgres if you are on like a medium scale. And that's where I come in, right? Because like right now with like PGVector Scale and PGVector, I not only have my data co-located, which is really important for me, but also like I don't have to manage 1,000 different places, right? Because I had the same issue. I had embeddings that were kind of stale. And I also had this issue where users deleted stuff like from Supermemory, but when they asked a question, it still showed up. And like and the indexes could only be a max of 64 bytes for like storing vectors. So I had to have this entire system of uh, like compressing an index based on like it's like a very complicated system that I had to make. And for some reason that kind of complicated system failed and like the deletion did not work. So I had like let's say 10 million vectors in my vector database, and I had much lesser in like my actual documents. So that's when I realized, okay, I'm running into scaling issues. I'm running into these issues. I should probably move to PG. Um, and that's why I like settled on Postgres because it not only solved the code location issue, it also kind of solved the like when I update, I know that okay, I also have to update the embeddings. When I delete, like automatically the embeddings are also deleted. So that's also very helpful for me.
That's awesome. That's really great to hear. I think what I would also say is, we talked about the pros and cons of these different systems. What's really cool about AI today is that you have all these different options, and sure, it's overwhelming, but I think testing out different systems, seeing what's good for you. I think our philosophy is that a lot of developers already know Postgres and they know SQL. For example, I think Postgres was the most popular database on the Stack Overflow developer survey for 2024. So this year, and then I think also last year as well, 2023. And so, while it's good to experiment with a lot of systems and actually, respect a lot of, a lot of the work that other folks are doing, some of the time it's good to try the things that you already have familiarity with. And so I think what we're trying to do is give more folks that option such that, hey, you can experiment, and it's actually easy to get started to experiment because you can start with the database that you already know. And then, if you find that, hey, you have a special use case that requires this like really specialized system, then you can go and use it. And I think that's the beauty of having all these different options today.
That's amazing. Wow. This is so cool. I mean, that we've had it's like now been like about an hour and a half and 90 minutes plus and stuff like that. And a phenomenal resource of information. I think I titled the thumbnail saying, Vector DB Rethink 2025. And I think this is a really good time of the year with everyone kind of wrapping things up and kind of, people in bigger companies are, kind of slowing things down a little bit. And then they're kind of rethinking their strategies for the next year. And it's just, I feel like AI is kind of moving so fast, month to month with all these different advancements and tooling and stuff like that. And, everyone kind of sharing their experience here is just super, super duper rich. And I feel like we're just scratching the surface. That's just kind of what happens with these types of technologies. It's like you kind of get into them and it goes really, really deep very quickly. And especially for me, kind of on the entry level, it's just been really great to kind of, hear you guys kind of talk about this and kind of give me some options to go start playing around with and kind of seeing, what's going to work for my use cases after I start to go from, in my case, I'm 0 to MVP. Dhravya is like MVP to scale. It's like kind of that type of thing. And it's so cool to kind of have both of that in the room and to listen to you guys be here and stuff like that. So thank you guys so much for kind of, getting this discussion started and just to plant the seeds in everyone's minds to kind of start thinking about this in different ways. And so I guess I'll have Dhravya start first as far as like where they can find you, resources, and how people can even get in touch with you as far as any research stuff that you've published, where can they find you and all that stuff. And then we'll kind of move on. Yeah.
Yeah, so the best place to follow me is on my Twitter, of course. It's like at the rate Dhravya Shah. If you just like search up my name, you'll like hopefully find it. Also follow me on GitHub. Like all my stuff is on GitHub. Like almost all of my projects are open source. So like all my research, everything that I do is like the end result is there. So you can take my homework. That's fine. And yeah, that's like the two main places you can find me. I also create content on Instagram at dravya.dev. Like I know some of my Instagram audience is yours. So if you're here, post a story and like tell everyone about how useful this was.
That's excellent. Cool. Matt?
Um, Yeah, so probably the best place to find me is Twitter as well, at SevianNY. But most of my written content these days is on the Timescale blog, which I also think is a great resource for AI content and the general learnings. And pretty much everything under the AI tab is in some way related to what I've been doing.
That's amazing. Avthar.
Yeah, thanks so much again, Ray, for having us on. I think I really enjoyed this conversation. Would love to also hear more questions and things from people. So if you want to get in touch, I'm pretty active on Twitter. It's just at Avthar S. So if you just search Avthar on Twitter, Avthar, you should find it. Most of what we're doing is on the PGAI GitHub. As I mentioned, a lot of the all the projects that we do are actually open source, and so if you just go to the Timescale GitHub repo and you'll find PGAI. An easy way to do it is just pgai.com, and that should redirect you to the repo. And then finally, if you're interested in keeping up with me, I have a website and some writings up there. It's at avthar.com, so myname.com. If you want to keep in touch. But yeah, thank you so much again, and I'm excited to hear more. And hopefully, this is the first of not the last stream that we'll do together. We can jump on and hack around again very soon.
Definitely. Yeah, this is really cool. And I hope to have some more insights as I kind of start to develop my apps and have them grow and so forth. And so for those of you who are just watching, thank you so much for joining in on this journey from coming from different places, whether you're a very technical person, getting your hands dirty on this, if you're a high level C executive type of person, just kind of being aware that there's other options like this is just really incredible. You'll probably hear some of your employees talking about some of these tech. And just getting you aware, vector databases is just the kind of time to sit down and rethink things. And then also for those folks who are just building, who are going from zero to MVP like me, who are, rapid prototypers and using different tools and services to provide different experiences. It's just been really helpful to kind of look at that from that perspective. And while also respecting the technicals that are kind of happening underneath the hood. Because those kind of vary, like how I deliver an experience to a user and kind of what's happening under the hood. As far as kind of maintaining these types of things as these systems kind of grow in their different ways. And then also, Dhravya, who's taking this stuff and, actually actively scaling it as a young 19-year-old still in school, producing these products, having been an intern at Cloudflare, working on his app, Supermemory.ai, actively building, actively discovering, actively researching and sharing for us all. So stay tuned. Make sure you stay subscribed to us, Ray Fernando 1337. You can find me on X. On YouTube as well. This broadcast is going to be shared with others, and feel free to share this with friends. And I'll plan to have little snippets of this conversation cut up so that we'll have we'll have timestamps, we'll have resources also included at the various places. And thank you all for tuning in, and hope to see you next time because this is a really amazing broadcast. Thanks, everyone.
Yep. Thank you.
See ya.
Bye.
Bye.
Thanks.